So it's like a Mexican food for people that don't know the name, but so it's easy to remember. But I'm only one. I'm not the whole baggage. It's only single one. Not so. Yeah. I have a lot of stories about my name, but because they told me to be Greek today, I'll skip it. So yes, first I would like to introduce of. I'm going to tell you about the context of the technical things that we developed in the project, but because I taken the liberty to think that you don't need someone that speaks binary here and tell you all XML, RDF, OAI, PNH, and all this sort of thing. So I thought to do something a bit more lighter. So my intervention would be two parts. One, I will set you in the context of the project, and then I will give you a small demo of the platform, let's say, or the system that we developed. So basically, we are working on this transformation, this digital transformation. We are supporting the digital transformation of the cultural heritage set, right? So, and it's very interesting because we are in this digital revolution. And for the first time in the history of human history, we are experiencing and facing some shifts. So, whereas in the past, that makes a unique situation compared to the previous revolutions in human history. So one of them is that all the past revolutions were based on one, or were given by one technology change. So one technology changed the world. Whereas now we are experiencing this with multiple technologies that are working. A second shift is also the speed of the change. So previous revolutions were slow compared to what we are experiencing now. So now everything is very fast. So the cultural heritage world needs to adapt to this speed and be able to get the trained in the digital transformation to go to a good board. So to give you some context, I always say that it's important to explain how we do things or what we did in the project, but also it's more important to say why we did it. I think this has been basically covered in detail by the previous presentation, and those are the ideas that we presented before, and I learned them from Professor Maria Ioannidis. So, but basically, I want to highlight that this has an effect of the technology as the technological decisions that we took in the project. So, what we did in the project is following these two unique ideas that the EUreka3D project had developed in an innovative way. I don't think there are many projects in the world, and Maria might say that this is the only project in the world that is working with these two premises. One is that we are not trying to digitize things for the sake of digitizing. We don't want to get just the original structure of something and capture it and put it online. This is not the objective. The objective is to work on the memory trees, the memory of the object, that Marino said, is the history, what we are interested in. Not only to create this 3D object that we can share with the gaming industry or with professionals around the world. And the second one is that we use Paradata. And Paradata is very innovative in cultural heritage, at least in this context. And we need to not only document the information about the object, but also the information about the digitization process, how we did it. And this has an impact in the quality of the object. So these two reasons that we saw here are what are leading the developments that we did. So how we did what we did. So I usually like to start with this graph because it describes the workflow from start to the end. So you can see there are three phases: the capture, the cloud, and the delivery. So the capture is what Marinos explained before in his presentation. I think he was brilliant presenting this idea. So it all starts with a physical real object, and it goes through a digitization process by using camera sensors and so on. We get to these three types of, let's say, data. So we have the data that includes the raw data with the 3D, the 2D, the images, and everything related to the model. We have the metadata, that is the information about the data, so basically information about the object and the real object as well. And we use CDN, a European data model format, to store this information, which is an RDF, this based on RDF XML, so web of data. And then we saw Paradata as well. Paradata is, as it was explained, the information about the digitization process. Then we go to a second phase, that is the cloud. And this is why we entered the technological part of the project in this respect, because we are talking about EUreka3D Data Hub. So this EUreka3D Data Hub is the system that we develop as a solution to go with the needs of our community. And you can see here 3 components. The first one is authentication and authorization. The second one is data management, and the third one is compute power. And I'm going to show you how they work in practice in the demo. But basically, we implement in authentication and authorization, we implement the security rules for the users to access our system. So we use a tool called BGI Check-in. Authentication is the process of identifying the user. So normally we use biometrics or a password. This is the most common thing, is to say who I am to the system. And authorization is the boost that tells what you can do in the system. So those two have to be implemented, because we don't want, when we upload our better heritage objects, we don't want people to mess with them. We don't want them to change our data. We don't want them to access information that we don't want them to access. So for example, we can share some data with some other communities or some other better heritage institutions, but we might want to have it private as well, or public. So these are the boosts that govern the whole system for the access of the data. Then we have the data management, and in here we use a tool called Data Hub. And we use the storage, and we manage the system with this Data Hub. And I will show you in the demo how it works, because it's quite simple to use. And then we use another component that is a compute power. Those are virtual machines, servers, that we deploy to run specific processes that we need for the project. So basically we need, as Antonella said before, we have a viewer of visualization options, and this is the one that is in charge of making the bubble with the visualization. And finally, we go over, I should mention also that we upload this to a Nubia cloud, and this is one of the advantages. So we use national, EGI is a federation of normally national infrastructure and other research infrastructure, and we use European infrastructure from national providers normally to store this data. So it's very trustable, let's say. It's not like you have to send your data to the States or to any other place. So we respect GDPR and all the European law are compliant. So finally, we go to the delivery phase, and in here you can see the logo of V200. V200 is an initiative from the European initiative that provides persistent IDs. So these persistent IDs makes our assets fair, and also they provide a long life for the data that we furnish. And you can see here that we depicted 2 options: the user interface, that is Europeana. So we integrated with Europeana in a way that when you upload and publish data in EUreka3D Data Hub, you have it published in Europeana. So this is a very nice way for you to promote your assets, let's say, and to have them published in Europeana. And also we contemplated the option of download the specific data. So because Europeana, at the end of the day, you have the visualization and you have the metadata. But sometimes you need the files to work in your local computer to do something with the models. So to do this, you can download the data and you can play with it your own space. And of course, everything we are doing is concentrated EOS. EOS is the European Open Science Cloud, and it's let's say a playground for research infrastructures and research institutes and research projects to use the cloud and benefit from these technologies. So basically what we offer with EUreka3D Data Hub, I think it was summarized very well in Antonella's presentation, but I want to give also some insight, because this is what I'm going to show you in the presentation. So we have a solution that allows you to manage, store, share, publish, and preserve your cultural heritage objects. It implements as a functionality user authentication authorization, so you don't need to care about these things. These things have been resolved for you. So you want to share this data with specific institutions, you can do it. If you want to share it in the EUreka3D community, you want to share them openly and share a link with an external provider for them to download your data, you can do it. And you know that this is not in a secure environment. So you don't need to care about how this works. You just need to use it. It's simple as that. We use metadata in media. So it's something that allows or implements the interoperability with Europeana and some other institutions. We obtain the PIDs from B200, and I think this is not such a common thing to have PIDs in cultural heritage. So we are promoting these persistent IDs in a way that you provide an ID to an object and stays for a longer time, because our intention is to preserve this data. And then you have one of the star features of the Data Hub is that we allow the publishing in European, which means that you can visualize your object and you can publish your results in Europeana, go to Europeana and find it. So you also have this user interface for you that is specific for cultural heritage. So I would like to show you how it works in a brief demo, and I will show you all these components, how they work in practice. Okay, so I'm going to show you from the beginning. We're going to log out because, okay, so when you get to the system, you will see here the sign to login, and this is what I'm going to do. So this is the first component. This is the component that is going to authenticate me to say, okay, you are able to get in or not, and assign me the permissions. So basically, you have here, this is check-in. And in here you can use any institution coming from educating. Like for example, if you were at the University of Oxford, you can go to here and log in. Otherwise, you can look for your institution here if it's in educating. Normally, most of the research institutions are here. Then also you have other options to log in. So you can use Google, ORCID, LinkedIn, and any other option. So this allows you two things. The first one that I think is important is that you keep a single identity, digital identity. So when you try to log in here, the system knows that it's you. You don't need to create another password that you need to share with EGI, because why should you trust EGI with your password, right? I mean, yeah, we are trustable, but you don't have it's a bad experience. You don't need to share your password with your boyfriend or girlfriend. Don't do it, please. Yeah, keep it for yourself. So it's something that it's good to not to share your password. And by using this process, if I go to Google, I don't need to share my password with EGI. So Google is going to authenticate and say EGI, okay, this person is who claims to be, you can go in. So authentication goes through Google, Oxford, or whatever institution you trust. Normally your home organization, we call it, is the institution where you work. So this is something that is nice. And also you have SSO, which is single sign-on. It's an option for you to log in once and stay logged in. So for example, I was able to access so I have to log out before, and I was able to access because I already logged in before. So you don't need to log in again. I'm going through the process now to show you how it works, but normally you don't need to do it several times. You just do it once, and then you remain logged in for the whole of your history. Well, not light, because it expires after 6 hours or something, so there is a security measure, but so that's what the password. So yeah, I log in here, and you can see the system, we have the data space of EUreka3D here, and then you can see some files that were uploaded in the system. For the demo, this is the real system, but for the demo, I'm going to do some changes in our testing environment, because I don't want to mess anything up. Also because if I do something here, it might create a real PID, and this is not something that is desired, because PIDs are supposed to last forever, or as long as possible. So yeah, I'm going to avoid the creation of these. So this is the testing system, which is exactly the same, but with some limitations or some differences, because it's for testing, basically. So you can see here the testing space of EUreka3D in the same way, and I'll show you how you can create the information.
So in here, normally what you can do is to start a project. So when you start a project, you just run this process that you give a name. It could be, I don't know, Cathedral. The Cathedral of Girona. And then you can manage the groups to say who in the EUreka3D community can access your information. So in this case, because this is a testing environment, we don't have everyone here. But in the real environment, you have all the institutions that belong to EUreka3D, and you can set up and say, okay, this institution can access my data or not, and you can share your data with other institutions within Eureka. Basically, this will run the process, and well, you don't need to get into details, but what this is doing is creating the whole structure for you. So we have a process that is creating a template for you. I mean, it's not necessary that you run this, you can do it manually, but this is a very convenient way to get your project started. In a way that we are contemplating the VG study to divide the quality of the object, the different folders, let's say, and you can work on them. So this is a structure that was created for you, and we have the reconnaissance, the preliminary, and the detail. So those are the different quality letters according to the VG study where you can upload your data. So in here, in this folder, you can upload the models. This is just a convention. So you don't need to follow this, but this is convenient because everyone else knows what to expect from this folder. So in here, you can find the information about the rough object. So things like that can serve for or can be valid for the gaming industry, for example. When your models are not detailed or as detailed as they could be. And detailed is the highest quality possible for your model that you upload here. Granular is something in the middle. For this, I would recommend to check the VG study because it is all explained there about the quality of these things. Then we have paradata, where you can upload the paradata of the visualization. And then we have a folder called viewer. That is where we normally input the files that will go to the viewer. So inside here, you can organize the data as you like. And the way you do it is very simple. You can just drag and drop files. So for example, I have this and I can drag and drop and it's uploading. So it's as easy as this. You can even drag and drop folders and create a folder structure. And then you can organize your data as you like. So you can say, okay, I want a new directory and I want a chemical analysis. And you create this, and then inside here you can upload files as you wish. So you can put files inside and organize your data as you prepare. You can also share the data from here. So you can say share copies, and then you get a URL that you can share with other institutions and other people, so they can go and access your data and see the files that you have here. And also the most important part is the publishing. So for the publishing, you publish as open data report. So this is another shape. And then you go through this initial process that you need to choose which service. So this is to get the PID from B200. This is a testing account, so it's safe to use. And then you use the metadata format. In this case, we use Europeana data model. So we are going to share this object. We put the object in a zip file, for example, your 3D models, and now we want to share it with Europeana. The way we do it is that we go here and we describe the metadata of the object. And for this, you have two options. You can go directly to this form. That is an easy form to put the values of in EDM format of the model. So for example, you can see it's made of concrete, the title. You can fill in here some of the details, right, about the R2. And this is all EDM. I don't want to get into much detail, but it's basically based on EDM. And apart from this visual form, you can use the XML. You have advanced knowledge to do it, and you can change it directly here. You will see that this is reflected also in the form, and you can directly modify the EDM file or metadata in XML RDF. So this is just if you need, for example, to do some advanced things that is not contemplated in the form, or if you have another tool that is provided you the idea, you can use it and copy paste it here. Once everything is done, you publish and it's done. So I'm going to show you how it looks with a real object. So what we look for? Yeah, both above, for example. So once you publish, you will see that the file gets this share icon. And this is basically what you get. So it's the data that we filled in before. So you can see here with a real example. There are both fishing quarter, the description, category 3D. It's made of wood, but it should be here. So those are the links. The dimensions, the creator, everything. So first we have a section for the content object, then the real object, then we have for the digital object, and then for the aggregation. And you can see all the information is here, and how this looks in EUreka can be seen here. So you go to EUreka, you look for the La Bolsa visible, and you have this here. The metadata is what we described in the platform, that is sent to EUreka, and then you have the viewer here where you can see the object actually. So yeah, I think I'm late. So, but it's basically it. So here you can visualize the object, check the object, and work with the metadata. If you need further information, you can go to the platform, share a link, and they can go to the object or to some parts of the object that you want them to download, and they can do it here. So they can go to some of the parts and say, okay, I want this model to download this, so you can share this folder with the textures and they can be reused. So this is basically sorry because I don't have too much time to talk about all the details, but if you have any question, please contact me now or during lunch time, and then we can discuss it. So that's it from my side. Thank you very much.